or somewhere else?
Yes.
We are live on YouTube.
Mm-hmm.
Yeah.
What is your YouTube channel's name? Is it the same with the student branch? Or do you mind to send me the link later?
We will share the link with you
Okay,
after the session.
Okay, thank you.
So I think we shall start. Yes. Greetings to all our participants. I request everyone to mute. Yes. So I welcome you to the last session of IEEE Virtual Symposia, which is themed on power and energy technologies. So I welcome you all. And before we start today's session, I request our branch counselor, Dr. H.K. Sardana, for his welcome address.
Good evening, dear participants. Let me welcome Simay Akar, another woman in engineering and also a woman in power. I really look at the topic, which is about clean energy technologies for sustainable development. It sounds that Corona and climate has been the recent problems, and clean energy could be a way out. I would see the speaker probably connecting these two. And I saw her profile. She's into commercialization, into business development, marketing on various aspects of energy. I hope we'll learn a lot from her, the marketing and distribution and other aspects of energy in general, and probably the scientific details and how clean energy technologies could help us towards sustainable development, the way the topic says. So thank you, Simay, for agreeing to be a speaker for this session. And I hope the delegates will enjoy your experience sharing. Thank you once again and welcome everyone.
Thank you, sir. So before we start today's session, it's my pleasure to introduce our today's speaker, who is none other than we have with us Simay Akar. So Simay is specialized in solar and renewable energy industry since 2012. She worked in China and Turkey and mostly focused on international commercial activities, including communications, marketing, sales, investment management, and business development. She currently serves as Chief Commercial Officer at Renewables, Shanghai at New Energy Technology Corporation Limited in the field of energy storage for renewable energy and electric vehicles. And she is in charge of global marketing and business development activities and initiatives. She served roles as Sales and Marketing Director at various other firms like at Ecore Renewable Energy, Business Development and Marketing Director at Good V Solar, Head of International Marketing Department at Solar Business Development and Sales Manager at CSUN and Marketing Communication at Electric and Corporate Communication at BECO. She joined IEEE as a student member in 2007 and graduated from Middle East Technical University, Ankara, Turkey. And today she is an IEEE senior member and has certified also as a soft skills trainer since 2008. And she's also the Alumni Association Energy Commission member and licensed sailor athlete at Turkish Sailing Federation. So with this brief intro, I welcome you, ma'am, for your talk. Over to you.
Thank you so much for the invitation. It's nice to be here, and thank you for the introduction. I would like to change the screen, but I can't. Okay, yeah, I can. So you already introduced me with many details, so I would like to just shortly say that I'm in the renewable energy industry for a while, that I also gain experience from both technology perspective and commercial perspective, and currently my role is the new energy, which will be the name Innosis later, as a new brand in the energy storage market. So I'm one of the founding partner in this company, as working as a chief commercial officer. And this is a Chinese company for renewable energy projects and electrical vehicles. So we are like a battery manufacturer. So you can get some more information about me later, but I would like to highlight I ended up in the power energy industry thanks to IEEE. IEEE really helped me to shape my life from the student years. I've been member also in several technical societies, but of course I need to highlight Power Energy Society. I'm also member of Industry Application Society, Social Impact of Technology, the SSIT, and several others. But I start working in the solar industry. First time I was in charge of solar cells, as you can figure it out from the picture, as my first job, and also I've been involved in different parts of renewable energy industry with my different roles in my day jobs. So today I would like to highlight the importance of clean energy technologies for sustainable development. So all around the world, with our volunteer positions, with also, like in the industry initiatives that we take, we are trying to leverage clean energy technologies for humanity. That's really important for our future. And even these days that we experienced pandemic in 2020, so we learned one more time how important it is to have clean energy technologies and be independent on the energy generation in many parts of the world. In the early 2020, we experienced first time the pandemic. We didn't even know how to deal with this, and some of the borders closed, right? And so we start discussing about the importance of the clean energy technologies one more time. So it's really important to be independent for the energy generation, for the future of humanity, and for all of us. So actually, I would like to refer some of the report results that this chart is from IRENA, Global Renewable Energy Renewables Outlook. So of course, there's so many different scenarios, like for renewable based power generation and global outlook. So I would like to just share some of them during this presentation also. According to IRENA is International Renewable Energy Agency. So we will have 86% of the energy generation, power generation by 2050 from renewable energy. So today it's not 2017, of course, but more than 25% of the total power generation is from renewables. But by 2030, by 2040 and 2050, even further, we will see the increase of the share of renewable energy resources on our power generation. So when we just look at the renewable energy share and energy efficiency improvement rate, again, by different scenarios, we are seeing serious increase on the shares of the energy intensity improvement rate and renewable energy shares in several clean technologies. So here, there is a, give me a second, I think there's a just duplicate here. Don't mind, I just stop sharing my screen for a second. Okay, so can you see my screen now?
No, not yet.
Not yet, okay. Here's coming. Okay.
Yeah.
Now you can see. All right, let's fix it. So I would like to share a little bit more about solar outlook. So according to several results that you can find different estimations for the future, but according to Solar Power Europe, so I would like to share what has happened already by the end of 2019 and what is the estimation by 2014, which is actually in 3 years, in 4 years. According to several different market reports, there are different estimations, as I said. But here, they're always like optimistic scenarios and pessimistic scenarios. So like, because we only have expectations and estimations for the future, because renewable energy industry, it really depends on the policies and changes, and it's very dynamic. So even by every quarter, the estimations change a lot. So and even, you know, this year we were not expecting pandemic for sure, and for 2020 results, so we even expect for 4%, 5% decrease from the original estimations. But this is not the end of the scenario. So like, actually, the future is bright for renewable energy resources, because we learn how important it is for the future. So like, even several countries, they revise their policies to support renewable energy projects by the near future. So even we will see a little decrease in 2020, we will see more installations and more improvements from 2021 or the second half of 2020. So the outlook, the future is not pessimistic for the renewable energy resources. So I'm just like focusing here just for solar, and here that you can see the top PV markets for the world. Generally, it's not changing too much. So like the shares are just like dynamics between the countries every year. But China, for the supply chain and for the installations, is one of the most important market for renewable energy industry. So like supply chain, based on supply chain resources, so China plays important role, and you can also see the USA, India, Japan, South Korea, most of the Europe, but I can highlight here from the results, Germany, it's not written here, but France and Netherlands, Spain, Ukraine, these are very important the last couple of years in the renewable energy, in particular solar energy market. In the Southeast Asia, we are seeing also Vietnam and Australia also plays very important role. We call them as like gigawatts market. Their installation estimation in 2020 and the further, they're about gigawatts level. So we are calling them like a gigawatts market for solar energy industry. And you're also seeing the shares between the regions, Middle East, Asia Pacific, Europe, Americas, and the China itself, because China has more than 26-25% almost every year. In the past several years, that China was even more than 25%. So it will continue and keep the role as important in the solar industry from now till at least the next 5 years. In the annual solar PV market scenarios, you will also see the shares between countries is not changing that much, and the China itself, it has a huge market, and Asia Pacific, Europe, Americas, North America, and Latin America, they all growing so fast. So like that's why we are seeing the renewable energy market quite bright, and the future will be bright also. In this case, the policies are important to lead these markets. So there are so many countries, and let's say just regions like European Union, there are several regulations to support renewable energy markets. So we're just talking about the estimation for the installation from these results, but these will also lead the improvements and also the R&D resources. When we have a larger demand, we will have better investment for R&D, and then we will see more improvement also in the technology. I'm going to talk more, but I just wanted to give you a little bit large picture about the industry, how the industry looks like from the commercial perspective. So I want to highlight one concept here. So we're familiar with smart cities. We're familiar with the sustainable cities, like sustainable. We already learned a lot about this field, but actually the future will be smart and sustainable. You can also call green cities. It's just the smart city itself is not sustainable. So when you have also the sustainable resources in this integrated systems, we call them like smart and sustainable or green cities. They're great samples and pilot applications and pilot cities around the world. It's not easy for this transition, but the world is going that direction, and there are some funding opportunities for these kind of cities. For these kind of cities, that we are also using the energy power generation resources as renewables, and also the rest of the cities are smart. So the electrification is important, plays important role also in this concept. And here we have in IEEE, I just want to give a little break and mention that we have so many initiatives and so many technical societies in IEEE. So these two are also very important initiative in collaboration with several IEEE technical societies, IEEE Transportation Electrification Community, and IEEE Smart Cities Initiative. So there are also important standards by them. So we, as IEEE, we're also leading this area. So here that the IEEE International Smart Cities Conference is going virtual this year. You may have a chance to check it out, and if you have any interest in this field, you can also participate or follow the news and hear that we also had IEEE Smart Cities Planning Technology guide. You can also scan from this barcode and get some more information. But all of these information is available on IEEE Smart Cities website. So we're actually seeing the energy systems are more electrified in every scenario, and this table is also from IRENA Outlook. So like by 2030 and 50, then we're seeing the renewable energy share in the electricity generation is increasing, but also electrification share of final energy is also increasing. So even this year, like in 2020, the share of electric cars increased more than expected, and especially in Europe, in China, and Asia Pacific, in some cities we already have serious increase. We're not just talking about 2050, we're just talking about these years. And even this year, European market share, electric car shares dramatically increased. So like actually this market is growing more than expected, faster than expected. And actually, so we're just not talking about sustainable resources and renewable energy resources. We also have new trends in the energy transformation. So we are just talking about digitalization of energy production and consumption. This area plays important role also for the future new initiatives of electricity. We have a new concept in last couple of years. So like we used to be a consumer like very long time for the electric power generation. Now we are prosumer. So like this is the future trend. Actually, we are in transition. We are going to that direction. What is prosumer? So you actually consume. You don't just consume only. You also produce. So that's why we call it prosumer. It's a new concept, a new trend that we are talking about. Prosumer concept in last couple of years. So which means actually the distribution generation. So even when you check out these renewable energy outlooks in detail, especially for solar or more off-grid systems, you're still integrated to the grid, but you also you produce, you consume, and you actually connect with the grid. So in two directions, you don't just receive the outcomes from the grid. So you actually have interactive relation with the grid systems. So that's why we have we're talking about actually smart grid systems, and they're more important than and they also gain importance for the future because we are already prosumer, and every single day the prosumers will increase, and it will be more demand on this concept. So about the technologies in renewable energy, sustainable and clean technologies. So we can start talking about solar energy technologies. So if you're familiar with solar energy technologies, so it's actually generally called the photovoltaic panels, right? So photovoltaic panels raw materials is a solar cell, and the solar cell has also previous steps, manufacturing steps, which are like wafer, ingot, and silicium. And each of them has a different manufacturing steps, but at the end, then you have this photovoltaic panels. But solar cell is actually the the area that we have an important technological improvement, and solar cell itself can be applied in any surface under the conditions that we want, and this is actually the future direction for the solar energy technologies. So like in maybe like last couple of years, but maybe 10 years, that we kept talking about only photovoltaic panels because they're in mass production and they're cost efficient. So like for this industry, investment really matters. So if the cost is feasible, you have more demand. So that's why we were always talking about photovoltaic panels. And if you're familiar with technology, we have monocells and polycells and several different new technologies applied on these cells. But actually, there are new technologies are coming already. So at the R&D level, around the world, several important institutes, they're actually keep working hard to improve these new technologies for the future. So, but I would like to highlight one. One of them is the perovskite technology. So for the tandem cells, so this is about to be at the mass production level already. So the solar cells are more efficient, so can be applied in any surface. Could be even applied on the solar cell surface to make it more efficient. So, so we are just talking about increasing the efficiency in any solar cells with the tandem cells, for heterojunction cells, mono, poly, mono-PERC, IBC, and the TOPCon. These are the technologies we're now talking about. So like the target is increasing the efficiency, and the overall target is decreasing the LCOE, which is the levelized cost of electricity. So like all the R&D improvements about these area, and of course solar is not all about all renewables. So we also have wind energy resources, and we have the geothermal resources, and biomass is very important also. Then there are a lot of improvements are happening at that field. So and the hybrid systems are so important. So like the combination of the clean energy technologies are really the best solutions. Even for every country, there are several renewable energy resources are possible, but not every country has the same efficiency for these resources. So the hybrid renewable energy systems in one space, or the combination of the renewable energy resources according to conditions would be the best solution for the results. So, for example, I would like to highlight one of the best examples for the renewable energy resource, like one of the best example for the renewable energy. I want to highlight one country, actually, the Costa Rica. So Costa Rica is about to reach 100% renewable energy these days, but they're really working hard. And their resources, I didn't highlight it yet, but also we have the hydro as a renewable energy resource, of course. And Costa Rica's resource is actually mostly the hydro, and they have also several other renewable energy investments so far, but they're trying to reach out 100%. They're at the level of 99%. It sounds really cool, but when we just like look at their model, they're trying to invest more in the alternative renewable energy resources to reach out 100%, like photovoltaic, because at a certain level, it's not really easy to reach the 100% yet, but they're very close. And so it actually shows us the importance of the combination for all renewable energy resources. So they actually support each other to reach out the target level. And so like for every renewable energy, clean energy resources, so another future direction is energy storage. So energy storage is important because this is the main concern, and actually one of the main problems we have been discussed over the years. But we are seeing the serious improvement on the energy storage systems that actually finds the solution for the problems and the loss of the power generation from these resources. So like when we combine in the hybrid systems, when we combine with the right energy storage solutions, so we are having the best results from the clean energy technologies. So I highlighted actually the solar cells earlier. So of course, when you have the photovoltaic panels itself, panels is the place that you get the power output directly. But solar cells can be applied in different surfaces. You are seeing also the solar cars, and of course that they could be like the combination between the electrical vehicles. So we are seeing serious improvement in that field, but you're just like seeing the solar cells on the roof covered by the solar cells, the roof covered by the solar cells, and you generate the power when you drive. But this is the future. But according to current improvements, that there is no car yet can generate the power only from roof. So you still need to charge your car from the stations. But that's also another improvement area. Then R&D is working hard for these electrical vehicles with the solar cell roof. And the first picture, you're actually seeing the agricultural photovoltaic systems. So, and the other one is the floating solar. So here that we apply the solar panels on the systems, but why they are important? So for the agro PV, so agriculture photovoltaics, so like it was also another concern over the years. So in some countries, current country regulations don't really allow using the agricultural fields for renewable energy installations. But actually, this is not just for the using the land and the resources efficiently. There are also several benefits for the ecosystem when we have this agro PV. So like you have better outcomes from the agricultural field under the panels. The difference is the materials and also the construction, which is normally, if you have seen any photovoltaic installations, they're much shorter and the distance is shorter between lands. But here they're actually about 4.5 meters high. And they're just like, you have the sunlight, but also the agricultural land under the solar panels and the installation, you have more protected field. So for some products, for some agriculture products, you have even better results. There are some products, they're just neutral for this. So, but we haven't heard so much. It's very harmful for some products and so on. So generally, there are a lot of benefits. And the floating solar, you're seeing they're just like applied on the surface of the water. They're mostly lakes. And again, it was questioned a lot, but according to results and the research results from this floating solar, we're actually seeing also the benefits for the ecosystem under the solar panels, which is the ecosystem of the water. So when we presented the results at several places earlier, we have been asked for these questions a lot. But this is also another great improvement. But for this one, it's not like solar cars, but the solar panels are on the surface, so they're just like it's all about the construction. But there are a lot of improvements to make it more efficient on the surface. But there are serious numbers of installations already all around the world. There's one in South Korea. It's about 2.1 gigawatts for one project, but the size really doesn't really matter. You can apply on any surface anywhere around the world, so which is great. So if you're actually using the land more efficiently, and it's good for the ecosystem of the water where you apply. And if you have just a small size of the lake, you can still apply anywhere. And here there's just one more thing I want to highlight. Solar car parks, which is actually pretty normal these days. Well, this is the ideal model for, we just talk about the sustainable cities. So we should generate the power from anywhere, and you can just like, this is the ideal model for the future, as will be our new normal. We drive the electric cars and park our cars in the shade of the solar panels, where you have already the power generation there, and you charge your car and you continue, just you keep working, or you just like charge your car and continue your life. It will be like a not only future trend, but it will be, it's already our new normal in some parts of the life. We'll see these models more. And of course, solar cells can be applied in any surface. As I said, they don't have more pictures from those, but can be applied on the curtains, or there are solar roads that you're actually driving, and you're charging your car when you drive through those solar roads. There are samples already applied in different parts of the world. So it's obvious that we are going to more renewables by 2050. We are already there. So like, as planned scenarios, there will be a lot of job opportunities in the renewable energy sector. And it's important to place ourselves in our specialized field. And there will be new trends coming up. There will be a lot of entrepreneurship and also investment opportunities. So here you're seeing globally that the renewable energy job opportunities are increasing, but of course not the same level all around the world. But all the scenarios are really optimistic. You can see these results in anywhere. This is just the survey results and an estimation from IRENA's report, again, from International Renewable Energy Agency's report. So we're actually seeing, especially Southeast Asia, is growing. So the renewable energy efficiency, electric vehicles, and also in addition hydrogen, I didn't highlight this yet, but also the hydrogen, they are improving so fast in upcoming years. So that's the future direction, and we will see also increase in every different aspects of the renewable energy and all the clean energy technologies that we call them all together. Here, that is, you're seeing the increase by 2050, around 45% in the renewables, 26% in energy efficiency, and 23% in electric vehicles. And the green and blue hydrogen is also increasing slightly, but not that much, like renewable energy resources. But they're all integrated. So like we're actually seeing the world going that direction for more integrated, more hybrid, more like the combination models for all of them. So there will be a lot of new investment opportunities. So like by 2050, every countries have their own resources and their international resources. It's and R&D funds will also continue to and that will help also to improve the technologies, make it more feasible. So if you're planning to be investor in the future, or just do your own business as entrepreneurship, as entrepreneur, there will be a lot of opportunities. So like when we're just talking about the clean energy technologies and all the improvements and so on, it's actually our part of the life. So like we have already a lot of renewable energy goals, climate goals, and the policies and scenarios all around the world. They're all together helping us to reach Green New Deal. So I want to also highlight the Sustainable Development Goals. So renewable energy, clean energy resources, sustainable cities, and the electrification of the vehicles. These are very important also from this perspective too. And there are a lot of opportunities from also IEEE. If you're probably familiar with the humanitarian and philanthropic opportunities. So here we have several IEEE programs and initiatives. They're under humanitarian and philanthropic opportunities. They're working together and in their fields. There are a lot of funding opportunities, and also as a volunteer, you can get involved. Here, I think this is the last slide I have. Thank you so much. We can continue with the questions if you have, and then.
Yes, thank you, Simay, for a very wonderful and insightful session. So we have two questions in the chat box window. So I can read them for you. The first question is from Nishant. So he's asking that what is the scope of floating solar panels?
Yeah. Sure, I think it was asked during the presentation. So like the scope.
Yes,
I probably already referred and highlighted there, but it's just like we apply them on the surface of the water. So it could be sea, but mostly lakes, or not just river, because they should be a little bit stable, but more stable waters we prefer. And it's all about the construction. So they're like a normal installation as like a ground project, but the land, instead of land, so the surface of the water is the installation base.
Okay. So Nishant has one more question in the chat box. So he's asking that, ma'am, I am a postgraduate student in solar power system and want to have further research in renewable sources. So can you give me some guidelines to do so?
Okay, so there are a lot of opportunities for that. Depends where you want to specialize yourself, but you're already PhD, right? The question.
No, he's in masters. He's pursuing his masters.
All right, and of course, it's important to choose your specialization area if you want to go for the industry or the PhD, because this is the field that there are a lot of new initiatives coming. So it's important to find out where you want to see yourself for the future.
Okay. So next question is from Aryan. So he's asking that, ma'am, how are you working to increase the efficiency of solar panel by keeping in mind that high temperature decreases the efficiency to great extent? So what type of cooling techniques you implement and why?
Okay, so like how we increase the efficiency of solar panels is all about increasing the efficiency of solar cells. So this is another research area that we keep trying. Not only research institutes, also the photovoltaic panel and solar cell manufacturers, they keep working on the research of the solar cells and try to increase the efficiency. This is all about the improvement in actually solar technologies. So we keep working on that way. But the cooling techniques, so like for the solar panel itself, there's no cooling techniques. If you're familiar with the manufacturing process of the solar panels, you have glass, backsheet, solar cells, and EVA, and you laminate them. Or either in new technologies, we have the glass types. So we have still the same process: glass, EVA, solar cell, EVA again, and glass, and you laminate them and you frame them, or we have a lot of models without the frame too. So this is actually how we manufacture solar panels. So it's not, there is no cooling techniques inside, but this is the standard types. I just forgot to mention the bifacial cells, bifacial panels. There are also new panels in the last couple of years that we also the power output from the backside of the solar cells. So this is another type. But we have the hybrid panels. So these are not the standard panels. So there are new types. There are improvements in that area. So like you have the water at the back side. So and this is like a more combination. It's not like CSP, because concentrated solar power technologies are totally still solar, but it's different than photovoltaic. But in these hybrid models, in one panel, you have also the water system in the surface. You actually heat the water at the same time. And in one side, you have the photovoltaic cells and you generate the power. So in this kind of new types, there are some cooling opportunities. But for the standards and the standards panel, there's no cooling technique for one panel. So it's not possible, because the manufacturing and the raw materials, there is no like a technology behind.
Okay. So next question is from MN Jyoti, ma'am. So she's asking that, could you comment on any recent new application of solar energy?
Okay, so recent applications.
Yes.
I'm just trying to get the question as right. So the recent applications is based on technology or based on the installations?
I guess on technology she's asking, like new application of solar energy.
Okay, so like here we have, it's not that new anymore. I just recently mentioned the bifacial panels. So like the because probably from 2017, the solar panel manufacturers, they slightly changed their production capacity and have new technologies as like half-cut cells and the multi-bus bars and the bifacial. These are like the new technologies for the mass production. So like, and today from 2017, 16, we are seeing more of these technologies or either combination of them. And we have also the heterojunction panels, which are a little bit more efficient. And there are some new technologies can be applied on those panels as well. So the solar cell itself is heterojunction. By nature, heterojunction cell is bifacial. So you can even use it bifacial by using the glass model, or you can still cover the backside with the back sheet, but the panel, the solar cell itself is bifacial, but you can connect them with bus bars. So like, but these heterojunction panels, like there are some European manufacturers, they have the equipment, the manufacturing equipment for this kind of panels. We call them smart wire. So like you have no bus bars. So the solar cells, they connect from the corners, from the edge of the solar cells on the panel. So actually it's more like a smart. So this technology called like smart wire. So the world is going that direction.
Okay, thank you. So next question is from Shrey. So he's asking, how fast will a 100-watt solar panel charge a 12-volt battery?
Okay, so it is like maybe so it depends. So there are like calculations, of course, but it's I think it's no. We can just like go to the next question.
Yeah. Next question is from Sardana sir. So sir is asking that how do they manufacture flexible solar panels for cars, etc.?
Okay, so that's a great question. They're flexible solar panels. So that is they're already flexible solar panels, but we see like you can apply these flexible solar panels on any surface. Already there are some boats, ships, but in today's technology, it doesn't have to be solar flexible panel, because there are ways to install and apply the solar cells directly to surfaces, like the picture I showed earlier. So it's not the solar panel you apply on the rooftop. It's already a technology that they improve, and the solar cells are integrated already in the rooftop, because you know, like the solar cell itself generates electricity, but you need to connect them and get the power output, right? In earlier, like of course they need to be connected, they need to be like integrated to each other, and you need to get the power output somewhere. But these systems already at that level that they just like they can apply on any surface. And I mentioned also the perovskite solar cell technology. It will be also like more flexible, and actually you can apply on any surface. It's more like liquid. You can check that one out. Again, I repeat the name. It's perovskite technology, but it's not in the mass production yet. There are some research institutions, like I can actually give the name. There's Oxford Institute, and there's one in Australia, Oxford in the UK, and they're planning a mass production, at least a small production line for this kind of solar cells and panels. So there are a lot of improvements, and this is a good sign for the future of the solar technologies.
Okay, thank you, ma'am. So next question is from Aryan. So probably this is the last question that we'll be taking. So Aryan is asking that, can you throw some light on emerging field of space solar power project? Space solar power project. So your valuable comments on this.
Okay, that's not really my expertise area. For that, that's why I don't want to share so much. I'm familiar with the project. but I didn't gain so much experience by myself. So I skip this question.
Okay, so ma'am, there's one question from my side.
Sure.
So, yeah, so ma'am, I'm working in the alternate fuels investigation. So I work on producing hydrogen from the photoelectrochemical water splitting. So I would like to know like your valuable comments on like hydrogen for a future fuel. So could you share your thoughts on that? Hydrogen
Of
as a
course.
alternate fuel. Yeah.
Of course, that's actually one of the emerging areas for the future. That's a great field to work for. Congratulations, all your work there. And you know, like then we just still talk about the other renewable resources these days because of the mass productions and so on. But according to several important uh, results and analysis, so we can see the hydrogen will increase the share in the short term, and it's actually the one of the future and highlights for the renewables and clean tech.
So thank you, ma'am. That gives me motivation. Yeah.
Sure, I mean that you're in the right area, and actually that was the highlight I tried to mention earlier for renewable energy, clean energy technologies. It's important to place yourself in one specific area and specialize there, because these are all the future initiatives. I mean, for all of us, like we should be really attached with that field. We should know that area better, you know, like then. And actually, I'm glad to hear you found yours, because that is just a really bright future.
Yes, thank you, ma'am. So before we end today's session, I request Sardana sir for vote of thanks. Yes, sir, over to you.
Thank you, Simay, for an interesting light on the topic, which is itself solar light, and how the transformations occur from one type of energy to the other. And I believe it is a decade now that this technology has been maturing, and material scientists all over and energy scientists and engineers have been pushing these devices into practice. So I find even in India and in other countries, they are all proliferating all over. And we find all buildings now becoming, there are government schemes, mandatory guidelines to deploy these solar cells. And as you said, I like the prosumer term that you mentioned, wherein we are no longer consumer and we are also producers. So it's a nice combination, and it is no more the billing on one side, but it's the billing on both sides. That makes it bipolar. And a very interesting, thoughtful lecture on solar panels and a lot of future. And I like that slopey increase in renewable energy you mentioned, about more than 85%. That is likely to come now. That shows a future for young engineers and scientists. I hope they will they would have enjoyed this, and they will see a lot of future in their career and research. So thank you very much for being part of this evening session, and we look forward to similar interactions. And there are people probably who would like to connect with you for any future prospects. Thank you very much.
Yes, thank you, ma'am. Thank you, sir. And I thank all our participants. So we can have a group picture before we end today's session. So I request everyone to turn on your camera.
Hot start the day.
Yes, any more joining us? Okay, so Simay, I'm taking a picture. Yes, thank you. Thank you, everyone.
Okay, before leaving, I would like to share one of our upcoming event, which is on cybersecurity. If you haven't registered yet, you can visit this link and register for this event.
डिज्नी पे देख रहे हैं।
डिज्नी पे है क्या? साइट क्या है?
Okay.
Hotstar.
I request all the participants to mute.
हॉटस्टार पे?
Am I audible, Anupama? Okay. So this is the seminar series on the cybersecurity by the global experts, in which one of our IEEE president, Susan K. Land, is also invited, and Professor Ashutosh Datta and Professor Shiv Yu. They will share their insights on cybersecurity during this lecture series, and after this, we will be conducting a certification exam. So please join us for this event as well. Thank you.
Yes, thank you, Simay ma'am, for a wonderful session.
Thank you very much.